all ready to go with your experiment. You even wrote an analysis plan, and then some annoying outsider asks about the statistical power of your project. Do you have to do that too? The number of observations is usually not determined based on power considerations, but by the size of your greenhouse or the number of volunteers who want to participate. Well, the power is the probability of getting a significant result if the alternative hypothesis is true. Why would you not just carry out the experiment and see what happens? Well, if the experiment is only meant to give a student experience in doing an experiment, fine. Low costs, learning gains guaranteed, and whatever useful results you get are bonus. And if it is a pilot study, of course, you should go ahead too. However, if the experiment requires serious investment of time or money, or you may cause stress or pain to experimental animals, power should be a concern. If you have low power, either expand your experiment or seriously consider abandoning it and invest in something else. How do you do that, considering power? First, think of what size of an effect you would expect. The difference in grades between two different teaching methods could reasonably be around 0.5 points. The proportion of people choosing a specific brand after advertisement should increase by 5 percentage points or 10. The increase in yield following some treatment should be about 300 grams per plant to be interesting. Then check for the sample size you have in mind, what the power is for that effect size, and an effect somewhat larger and smaller. Do you think your investment is worth a try? A problem I know is that power calculations for t-test and ANOVA-like analyses require an estimate of the standard deviation. And you may have no idea. Here's a rule of thumb, assuming your measurements are normally distributed. We make use of the so-called empirical rule, which tells us that 95% of our data will be within 2 standard deviations of the mean, or 99.7 within 3 standard deviations of the mean. Ask yourself, what is the highest and the lowest measurement that I expect under standard conditions? Divide the difference by 6 and take the result as your estimate for the standard deviation. If your type of experiment is likely to have dropouts, take that also in consideration when determining the sample size. Don't fool yourself or others. However interesting and fun your experiment may seem, it is no use embarking on a mission impossible, unless of course you are Tom Cruise.